Hello everyone, my name is Farnood Sobhbidari and I'm a PhD student in the Department of Earth and Environmental Science at UTA. So this is the subject of my poster in ACES 2021, which is about investigating the frictional properties of shale organic matter with atomic force microscopy. So for this work, I prepared shale samples from lower portion of Bakken Formation in North Dakota, and also polished those samples with sandpapers up to the grit size of 1200. Then I used argon ion polishing for 3 hours. These are also more detailed data about what AFM instrument I used and what probe I used, which is CSC38A with nominal normal spring constant of 0.09 Newton per meter. And the conversion factor for lateral force that I got from wedge method has the average value of 299.14 nanonewton per volt. And previously, many research worked on just identifying the measuring stiffness properties of shale using nanoindentation or AFM, and they found organic matter is the most compliant portion of organic rich shales. But those research never ever worked on identifying the frictional properties of organic matter. So in first part of this work, I focused on identifying organic matter within the shale samples. So here we can see the SEM image of the area of interest in figure 2A and also the height retrace AFM signal, which is basically the surface topography on the figure 2B. And also the EDS data of the same area is shown here at different area, and analysis for different area is shown in this table, and 0.6, 7, 8, 9, 10 are dominantly organic matter. As we can see, their weight percentage of carbon is almost 60%. For the frictional, for the friction experiment, I changed the velocity from 250 nanometer per second up to almost 6 micrometer per second, and also the normal load changed also between 30 nanonewton to 90 nanonewton, and here we can see two of those data. So how about the possible relationship between friction force and normal load? Here we can see there exists a linear relationship between those two parameters, and for those three different scanning velocities. And here also on figure 6b, we can see there exists also the linear relationship between friction force and a natural log of the scanning velocity. So remember here, x-axis, the scanning velocity is in the unit of micrometer per second, and also then we got the natural log of those velocities and then found this possible relationship. And at the end, we also found out the measured friction coefficient of organic matter was approximately 0.25. And this is also the future work for this research. And at the end, a special thanks to Dr. Erika Laplante in Material Science Department to allow me to use her Cypher ES instrument, and also thanks to the Department of Energy to partially support this project. And thanks for your time and your patience. Have a great day.